As we know that when we talk about probability estimation, we are talking about some experiment or activity which is yet to be done. And since the probable outcomes are known to us, and we can also associate respective probabilities with those outcomes, so the pattern or distribution of those probabilities along with the outcomes is referred to as probability distribution. Means distribution of what? Distribution of probabilities. Which probabilities? Probabilities which are associated with the possible outcomes of an experiment. Experiment means we have understood any activity which is yet to be performed. For example, if we talk about tossing a fair coin twice, as we have done yesterday, and we are interested in say number of tails only. We are interested in number of tails as a result of tossing a fair coin twice. So how many tails are, what are the possibilities having some number of tails? If we toss a coin twice, we have done yesterday.
0.5.
No.
Four number of possibilities.
What are those numbers?
HT,
HT, HH, TH and TT.
STT, STT.
Please listen to me again. My question is, how many tails means how many different values of tails?
three, sir.
So three, yes, sir.
And those three are?
TH,
TT, HT, TH.
No, numerical value. How many tails? Different.
3 by 4.
There is one outcome where is no tail.
Yes.
See, if you want to assign some numerical value to the number of tails which are possible as a result of tossing a fair coin, so what are those numbers? Are you getting my question or not? If you want to assign some numerical value to the number of tails which are possible as a result of tossing a fair coin twice, what are those numbers?
So 0.25.
No, that is probability, not number.
4.
So 4. So 1.
What does that mean? 1. Say, now I repeat, out of those 4 outcomes, there is one where is no tail.
Yes, sir. HH. Yeah.
So number is 0. The other situation, the other 2 are where the number of tails is 1. And there is third, or you can say fourth outcome where number of tails are 2. So number of tails may be 0, 1 or 2. Now, so these are the outcomes, you can say, in terms of tails, if you are interested in tails. Similarly, we can be interested in head or we can be interested in any other outcome depending on the experiment. So what is the probability that there will be no tail?
So 1.
1 by 4.
1 by 4.
1 by 4.
0.25.
This screen you can see?
Yes, sir. Yes.
Okay. And what is the probability of having one tail?
0.5.
0.5.
0.5. And what is the probability of having 2 tails?
0.25.
0.25.
So this is what we meant by listing of the probabilities of all the possible outcomes of an experiment that could result if the experiment were performed. So if you are interested in number of tails, so here number of tails is called a random variable. What is the variable here? Number of tails. If I denote this number of tails by letter X, so X can assume 3 values, 0, 1 and 2. Is that point clear now?
Yes, sir.
Number of tails in our case is a random variable which we can denote by alphabet X. So X is referred to as a random variable. What does it describe? Number of tails. And what values this random variable can assume? 0, 1 or 2, because no other value is possible as far as number of tails is concerned. So this distribution, this pattern of probabilities associated with these 0, 1 and 2 is called a probability distribution. So this is what is written here. Variable means a quantity which varies with time or with any other factor. Random variable is when there is a chance factor associated with the various values of the variable, and depending on the nature of this variable, we can have either we can say either discrete or continuous variable, depending on if we can assume, if that variable can assume only limited number of values, then it is discrete, and if it can assume unlimited number of values, then it is a continuous variable. Say for example, if you are talking about marks obtained by students in a class, so which may vary from 0 to 100, and we can say it is a continuous scale. In some cases, the same thing becomes discrete. For example, in this case, there is no, 1.5 tails possible. There is no 0.75 tails possible. So depending on this, discrete or continuous is a relative term, depending on the nature of variable and the way you are measuring it. We can move further. Any question?
No, sir.
Okay.
So yes, can you please explain again this discrete and continuous?
Discrete or continuous means, as we understand by the meaning of the word, continuous means which can assume any value, means fraction values. Discrete वहाँ हुआ जहाँ you need to jump from one value to another value. जैसे for example, if we say income, income can be expressed as a continuous variable if you are talking in terms of exact money, rupees, dollar, whatever monetary unit. So it may be say from, for example, 0 to anything per month or per year or whatever. But if you say like in terms of categorical variables, that low income, middle income and high income, then it becomes discrete. Say here also, number of tails as a result of tossing a coin twice or thrice, as the case may be, will be either 0 or 1 or 2. It cannot assume fraction value, means 1.5 tails, not possible. So depending on the nature and the experiment, the variable may be either discrete or continuous. It may be more clear when we move further. Now, depending on the whether a variable is discrete or continuous, we can have either discrete probability distributions or continuous probability distributions. There are many. I've just listed 2 or 3 in each category, but there are many, maybe around 60 or 50 different distributions. If you go by any software and give some data, so that can fit into different type of distributions. But here we will be considering binomial distribution and Poisson distribution under discrete category and normal distribution under continuous category. Now we take up this binomial distribution. Binomial distribution has these characteristics. only two possible outcomes for each trial. जैसे अभी हमने देखा है tossing a coin, only two possible outcomes, head or tail in each trial, and the probability of success remains fixed over time. Here by success we mean the outcome or event we are interested in. अगर हम tails की बात कर रहे हैं तो getting a tail means success. If you are interested in finding probabilities of different number of heads, then probability of having a head is success. So success is with reference to the interest or of the interest of event or outcome. When as a result of examination, the result may be described as pass or fail. So if you are interested in finding out what is the probability of something related with fail, then failure is a success. And if you are interested in finding out probabilities related with pass, then that becomes success. Now, trials are statistically independent. जैसे हमने उसमें देखा था कि फर्स्ट टॉस के बाद सेकंड टॉस इज इंडिपेंडेंट. Whether it was head or tail in the first toss has nothing to do with the outcome or probability of head or tail in the second trial. So trials are statistically independent. So if a variable or an experiment or a situation can be described by these points, means there are only two possible outcomes of each trial. Trials are statistically independent and the probability of success remains fixed, then that distribution or that variable or that situation can be described using a binomial distribution. The mathematical part of binomial distribution you can see here, and we read it like this: probability of r number of successes, means number of successes we denote by small r. Somewhere it may be small x, so whatever it is. Vertical slash means given that small n is known, small p is known. What is small n? Small n is the number of trials. जैसे अभी हम यहाँ कहें हम what is the probability of having two tails in two tosses. So two tosses means small n is 2 because number of trials 2. R will be 2 because here getting tail is a success. So R is the number of successes. So if you are interested in finding out the probability of having two tails in two tosses, so two tosses are two trials, or you can say sample size. So small n is 2, small r is 2 because we are interested in finding the probability of two tails, and small p here is the probability of success. Probability of success means probability of getting head in any trial, which is 0.5. So it will be probability within bracket r equal to slash n की जगह 2 रखेंगे, कॉमा p की जगह 0.50, and this can be determined using the right hand side, factorial n over factorial n minus r factorial r and whole multiplied by p raised to the power r q raised to the power n minus r. What is q here? Any idea?
Failure.
Yes, probability of failure. So that is simply in terms of p, any relationship between the two?
1 minus p.
1
1 minus p.
Yes, because why?
Total probability is 1, right?
And there are only
2.
two outcomes.
Yeah, 2 outcomes.
So if p is 60% and q is 40%. Mean of a binomial distribution is worked out as np and variance as npq. Now we can take up one or two numerical examples on binomial distribution. Okay, let us do the second one first. Let us do the second one first. Spectrum Light Bulb Company went for mass production of bulbs in 4 different colors. 16 bulbs, 4 of each color, were packed in each of the boxes to be sold as a unit item. If 20% of the bulbs are estimated to be defective, what is the probability that a randomly chosen box contains? First part is at least 2 defective bulbs, second is at most 1 defective bulb, and third all defective bulbs, and fourth 6 non-defective bulbs. So let us first identify the left hand side of the expression, and then we will come to the right hand side. What information is given? By left hand side, I mean this one. For first case, what is R, what is N, what is P?
N is 16.
And the P is 0.2, small p.
N is 16. Yes.
P is 0.2.
P is 0.2. And for first case, what is R? Say
Is two.
except 2 or 3 voices, I can't hear others.
No, sir. Two.
So this type of paper, if you are not following, if you are not doing with the class, then it may be difficult to do it at home. I mean, in some cases, in an online mode, people think that okay, the lecture is being recorded, or we can get a photo of image of this, or we can get these slides, and then we will do it later. Then it may be difficult. So it's better that you participate, and your involvement is important. So N is 16, a small p is 0.2. What is R in first case?
2.
No, at least 2. So greater than or equal to 2.
Hmm?
Just to be greater than or equal to 2, right? At
Hmm,
least 2.
So how will you express R?
There is 2 cases.
R is equal to 2 or something else?
Two comma 3 comma in 16, up to 16.
No, what is the value of R? First, let us first decide.
So at least 2 defective also means even if all 16 are
Ajay?
defective, also it will be included.
Mr. Ajay?
Yes, sir.
How much is R? Jairaj,
8.
what is R?
8.
8. Imran, Faisal,
Sorry, sir, I have no idea.
उसी वही आइडिया लेने की कोशिश तो कर रहे हैं. Karan, what is R? At least 2 means what?
So 3.
At least means 2 or more than 2. There should be at least 2 defective bulb or more than 2 defective bulb.
Right. So R is 2 or more. Right. So if you use a mathematical symbol, so R is greater than equal to 2. Am I right?
Yes, yes.
Yes, sir. Yes, sir.
sir.
Yes, sir.
At least 2 means 2 or more. 2 or more means kitna more?
So total pack can be
16.
defective. See, yeah, up to 16.
Up to 16.
Up to 16.
Right. That means R equal to
2 to
or
16.
R equal to or R equal 3 or R equal 4 or I'm emphasizing on this or R equal 5 or R equal 6 up to R equals
16.
16. So an n will remain same, small p will remain same. So this way, if you want to calculate this probability with an expression that probability within bracket R greater than equal to 2 vertical slash 16 comma 0.20. If you follow this probability R greater than equal to 2 vertical slash 16 comma 0.20. ये आपकी left hand side. This is how you should first express what you want to calculate. Now the right hand side is सिर्फ R की वैल्यू चेंज हो रही है, तो पहली बार R इक्वल टू 2 होगा इसमें. ठीक है. n is 16 फैक्टोरियल 16 डिवाइडेड बाय n माइनस r मीन्स 16 माइनस 2 का फैक्टोरियल, फिर फैक्टोरियल r मीन्स 2 का फैक्टोरियल एंड होल मल्टीप्लाई बाय 0.2 raised to the power 2 and what else? Multiply by
0.8.
0.8 raised to the power
16 minus 2. 14.
14. This is only for r equals 2.
2.
Similarly, we will do for r equals
1.
3. No,
Sorry, 3.
3, 4, 5, 6 up to 20. And what will we do with these different values? Add or subtract or multiply or divide what?
We will
Add.
add, sir.
Add.
Why?
All possibilities.
Okay. Any other answer? Why will we add them?
Because of or.
Yes, because of or.
Yeah.
Because when we have or,
At least. Yeah.
not at least. When we have or, we add. And when we say and, we
We multiply.
multiply. So
Multiply.
it is r equal to or r equal 3 or and so on. So because of this or, all these probabilities will be added. So that means this exercise you will be doing how many times? R equal 2, 3, 4 up to 16.
16.
तो आपको इसको 14 टाइम्स करना पड़ेगा ना, 2 से 2 करेंगे 15 टाइम्स. ओके. That sum will be the probability of at least 2 defectives out of 16 if the probability of getting a defective is 20%. Are you getting this explanation? You understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, sir.
So process to understand कर लिया, but you know that if you do it like this, then it will be very complicated type of calculation. अगर complicated ना भी सही lengthy तो होगा ही होगा. So what we do, we make use of this statistical table, binomial distribution table, and but that gives only values. Which value? जो आप उसमें से देखेंगे. देखना कौन सा है ये समझना आपका काम. अंडरस्टैंड? तो ये पूरा एक्सप्लेनेशन जो डिस्कशन मैंने किया कि कैसे लेफ्ट हैंड साइड को पहले एक्सप्रेस करेंगे और फिर कैसे उसको एक्सपेंड करेंगे राइट हैंड साइड में, वो करने के बाद टेबल इज द रिप्लेसमेंट ऑफ दिस फॉर्मूला ओनली. टेबल values is not at all replacement of your understanding. You cannot get a direct answer from the table unless you know what you want to calculate, how will you add or subtract, or how will you see the table, and so on. So we now come to the table part. As you were told that please have your tables with you. Let me also have my table when check. So how many of you are having these binomial distribution table with them?
Yes,
If
sir.
somebody,
Yes, sir. Yes, sir. We are having
if
it.
somebody is not having, then he or she will be, it will be difficult for. I don't know whether which table, because tables may have different format also. Let me show my table. If you can see, can you see this?
Not very clear, sir, from here.
No, I mean, if you have your table with you and just have a look at this.
Yes,
maybe,
yes, sir.
Yes, sir.
Maybe they are the same.
Similar. Yeah, similar.
Okay.
Yes, sir.
So there is a header row. Header row means there are certain values like 0.05, 0.1, 0.15, 0.20.
Yes.
Yes.
They are small p values. Done?
Yes.
Yes, sir.
The header row of this table, 0.05, 0.1, 0.15, 0.0, and so on up to
0.5.
0.50.
0.5.
These are different values of small p. Now look at the leftmost column. What are the numbers there?
N.
Tribes.
2, 3, 4.
No, leftmost. 15, 16, 17, like this. देखिए यहाँ पे देखिए आप ये
X.
15, 16.
That is R.
Yeah, that is X. Yeah.
R.
नहीं, that is n. हमारे केस में that is n.
N, yeah, it is N.
It is n. तो सिर्फ 3 नंबर आपको दिख रहे होंगे, 15, 16 and 17, right? ठीक है? So that is your n.
So our book has 2, 3, 4, 5, 6, 7, 8, 9, 10, 20.
X
वो
up to N.
वो आपने the left column or the inner column, next column?
Left column.
Left column, sir. And there is a title small n. So we have this.
And is there next column also?
Yes, that is X, capital X.
Yeah, leftmost is N and then X.
What is that number? Second column क्या है?
X है sir. X है
0, 1, 2, and then for 0, 1, 2, 3.
increases.
it increases by 1. As n is increasing, that is increasing. X is increasing.
Okay, so whatever is your table, either you understand with this and compare it with your table. So if I look at this, maybe this is a simpler format, but you understand now what are the n and p and x there. So in our case, n is the number which is 16 in our case. Small p is probability of one defective bulb out of the lot, out of 16. That is how much? 0.20. And R is varying. R is varying from
2 to
yes,
14, 2 to 16.
2 to 16. Now you can obtain the values here. You can locate for R equal to first, where for n equals 16, small p is 0.2. Now try to locate with this two ordinates, try to locate where R equals 2. What is the probability? These numbers, which are as such 4-digit numbers, but they are basically after decimal. So 4 digits after decimal. So if n is 16 and R is 2 and P is 0.20, what is the value there?
0.211.
0.211.
Yes, correct. So that is 0.2111. It is here. So now you know how to read this table. So probability of R equal to when n is 16, small p is 0.20 is 0.2111. That is 21.11%. So you can note down this value 0.2111 plus. Now you will look for R equals 3 and so on. Add them all and then we will cross check the answer. Hmm? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir.
I'm just checking whether I'm corrected or not.
So 0.859.
Yes, sir. 0.8592.
Hmm.
Yes, sir. 0.859.
So means approximately 86%. So how do we interpret this? Means the probability of having 2 or more defective bulbs out of 16 is approximately 86% if there are historically 20% defective bulbs. Any question? Is this clear?
So can you please repeat?
The probability of having 2 or more defective bulbs out of 16 is approximately 86% if the probability of one defective is if of having a defective is 20%.
Yeah. Okay, thank you, sir.
Now the second part.
So can you move the slide?
Sir, can you please flash the question?
Thank you.
Thank you.
Sir, 0.1407.
Sir, 0.141 approx.
Yes, sir. So 0.141.
Hello,
Yes, sir.
I'm asking how will you translate this into R? At most one defective bulb. R
So
की R की फॉर्म में कैसे लिखेंगे इसको?
R less
So
than or equal to
14%.
R
Less than
सर मैक्सिमम 1 हो सकता है तो
Either 0 or 1.
Sir, 0 or 1.
Or 1.
either 0 or 1.
ठीक है, बट लिखेंगे कैसे? R what? Greater than, equal, less, what?
R less than or equal to
Less
1.
than equals to.
Yes, R less than equal to 1. And then you will be having how many values?
So 0.141.
नहीं,
So
कितनी
two
बार?
values.
So two
कितनी बार?
values.
Two values.
0 or 1.
0 and 1.
Yes.
0 and 1. ठीक है. So that now you can do for the third one and the fourth one. Now we come to the first example. For a binomial process with probability of successes at 0.8, determine the probability of getting 8 or more successes in 20 tries. So first you write it down in terms of R, means the left hand side. First you write down the left hand side.
So P of R greater than or equal to 8 out of 20 trials with a probability of 0.8.
Okay, and when you expand it, then it will be r equal 8 plus r equal 9 plus r equal 10 plus up to
R
20.
equal 20.
20.
20.
So, but the table that we have, at least I have, the small p is given up to 0.5 only. I don't know about your table because there are two types of table, up to 0.5 या फिर up to 1 भी होता है, वो फिर then it will be, you will be reading it from bottom to top. I don't know which format, which table do you have, but the table that I have, there the p values are up to 0.5. So how many of you are having this p values up to 0.5, or those who are having up to 1?
So 0.5 only.
Yes, sir.
Yeah, 0.5, sir.
0.5 only. Sir.
So 0.5, if you have
Up
that
to
point,
1.
up,
Sir,
okay.
up to 9,
So up to
0.95.
1. So 0.9, sir. 0.95.
Now, okay, if you have up to, means if you can see the values for p equal 0.80, then it will be done as we have done this bulk question, the second one. But if you do not have, for example, I do not have this p equal 0.8 in my table. So what we'll do? So either I calculate it using that equation. ये वाली, ठीक है? Either I calculate using this, but if I want to make use of the table, then there is a limitation with this because 0.80 is not given. So any idea what we can do? How can we make use of the table? Can you guess something?
So is the sum of probabilities
Sir, can
1,
you?
so we can calculate in other way, like 1 minus not getting.
नहीं, लेकिन 0.8 तो भी चाहिए ना, प्रोबेबिलिटी 0.8 तो भी चाहिए, 0.8 मेरी टेबल में नहीं है.
So for failure we can calculate now, like for 0.2.
Okay, good.
Yes, sir. For failure we'll calculate and then we'll subtract it from 1. We'll subtract it from 1. 1 minus q will be p.
Okay, but there will be another corresponding change. If you change q, means if you change p to q and its value from 0.8 to 0.20, that is correct, we can do because it is binomial. So either it's p or q simply. But there will be another change also. R will also be changed accordingly. क्योंकि जब आपने 0.2 कहेंगे, 0.2 is the probability of failure. Now we will talk R in terms of failure, not success. No, ये नहीं हो सकता कि एक तरफ आप सक्सेस की बात करें और प्रोबेबिलिटी दें फेलियर की. इसको
Yes,
भी
sir.
अकॉर्डिंगली चेंज करना पड़ेगा. तो वो चेंज क्या होगा? ठीक है, P का तो चेंज हो गया, Q जिसको आपने कहा 0.20 हो जाएगा. अब R जिसको हमने लिखा था R greater than equal to 8, how will you convert it into equivalent number of failures? नहीं, R पहले R को कुछ और कीजिए. फॉर एग्जाम्पल इट बिकम्स R
R
डैश.
is less than 8 हो जाएगा सर अब.
ठीक है,
Okay, sir.
जैसे हमने P को Q किया, R को R डैश कर दिया. अब बताइए इसकी वैल्यू क्या होगी?
So
R dash will
0
be
to
less than
7.
8. 0 to 7, right?
0 to 7.
क्यों?
So there will be a possibility that person doesn't fail, or like there are possibility that 7 times a person fails. So I think the value will be between 0 to 7.
Anyone else? If I say this is not correct,
Sir, in binomial,
Sir, up to 8 also, so 0 to 8, I think.
it's still not correct.
So we have to reduce the R less than 8 from the current this one, when we take the converse.
So what will be that? Acha, if R equal 8, what is R dash?
So 12.
12.
Yes. So if R is greater than equal to 8, what will be R dash?
R greater than equal to 12.
अच्छा
R dash less than or equal to 7.
12.
अच्छा ठीक है. If R is 9, what will be R dash?
11.
ठीक. So R dash is 12 or less. If you convert 8 or more into R dash, it will be 12 or less. So therefore R dash will be less than equal to 12. You understand?
Yes, sir.
Oh. Okay.
So R dash is less than equal to 12, vertical slash n equal 20, comma, small q equals 0.20. Now you can use your table. 0 से शुरू करेंगे. R dash equals 0 plus 1 plus 2 plus 3 up to 12. ठीक है?
So, but the value of p is limited, na? So value of p is limited, pointed. We are supposed to break the value of p.
नहीं, अब तो 0.2 हो गया ना. अब 0.2 हो गया वो. उसे 0.2 करने की वजह से तो R को चेंज किया ना.
Okay, sir. Okay, fine.
But what if n is not available in this chart?
Sorry?
If our n is not available in the chart.
नहीं, that will be available. If not, then I mean, तो ये तो आपके पास है ना.
In the current question, we have 20 available. But what if, say, it was 19? So 19 is not available.
If any of these variables not available in the table, then you have this formula on the screen. ये टेबल वहीं से जनरेट हुई है.
Okay.
Then you will have to solve it using this.
Got it.
Whatever is the case, if n is not there, or p is not there, r is not there, so the formula is there and you can calculate. Okay, now coming to Poisson distribution. Poisson distribution, the characteristics are...
Sorry, sir. On that question, should we do a 1 minus later because we took R prime or not required?
No, not required now, because R prime you have taken, but there also you have taken P prime.
Yes, okay.
So the answer is final now.
Okay. Thank you, sir.
The only thing which is possible, if we forget about this 0.80, whether it is available or not, the only thing we can do is probability of R greater than equal to 8 may be written as probability of 1 minus probability of R. Yes?
Less than or equal to 12.
नहीं, अब equal to नहीं. Only less than
12.
Less than 8. I am talking about the original case. When R is 8 or more.
Yeah.
So you can rewrite or express it like 1 minus probability of R less than 8. And then you proceed as usual.
Yeah. Okay.
Coming to this Poisson distribution, the characteristics involve rare events, means this distribution describes situation where events occur rarely. Rarely means number of trials बड़े होंगे और probability of success छोटी होगी. So that is what we mean by rare events. and events occur in the context of continuum of time. Events are statistically independent here also, like binomial, and at a given time, the event either occurs or it does not occur. For example, if we say we are, if we explain this rare event, then what is the probability of having two calls between 10 a.m. to between 10 a.m. and 11 a.m. at a call center? So this, I mean, it may be very low. A rare event means you want to know what is the probability of having two calls between 10 a.m. and 11 a.m. at a call center when something given. What is that? Is the average number of calls that a call center receives. So we are interested in finding out some event, occurrence some event in the context of time. What is the continuum of time here? 1 hour from 10 a.m. to 11 a.m. And what is event? Event here is receiving two calls. So either the third point here is at a given time, the event either occurs or it does not occur. Means either there will be two calls or something else. It is not like this binomial that जिसमें आपने अभी किया था कि अगर 8 नहीं है तो 8 ये है तो 12 वो होगा. ऐसा नहीं इसमें कि अगर 2 calls नहीं है तो फिर क्या होगा. That, I mean, we can't answer that. So at a given time, the event either occurs or it does not occur. Clear? Do you understand these points?
Yes, sir.
Yes.
Now,
So,
yes.
so does that mean that the total of probability may not be 1?
No, that is always 1. That is always 1. But the only thing here is, here either there will be 2 calls in 1 hour or not 2 calls. I should say, means like this. Event either occurs or it does not occur. Does not occur मतलब ये हुआ कि 2 calls की बात नहीं हो रही थी. अब उसके अलावा कुछ भी हो सकता है. It may be 1, it may be 3, it may be 0, it may be anything else. So we cannot add or subtract that number like we were doing in binomial. Okay, if there are 8 successes, then 12 will be failure out of 20. That is not the case here. And the mathematics of this Poisson distribution is given like this. Again, x is a random variable. इसको जो भी आप कहेंगे, whatever is the event of your interest, that is denoted by x. Small x is that number, exact number, what number. And lambda here is the mean number of occurrences per interval of time. In this call center case, if we say there are on an average 5 calls per hour, then lambda is 5. Done? Should I move to the next?
Yes, sir.
Okay, sir.
For a Poisson distribution with average number of successes as 4.2, determine the probability of getting at most 2 successes. So it's simply here now left hand side of probability, of the answer will be probability x is what? What is 4.2 here? What is x?
At most 2.
So how will you express now?
Sir, less than equals to 2.
This, please write this information, what is required using the left hand side. Probability x is what? Less than equal to 2, vertical slash, what is lambda?
Mean of occurrences.
2.
4.2.
4.2. So at most 2 successes means x is less than equal to 2, vertical slash, lambda is 4.2. So that means we need to have this probability value from the table. If we are not using the formula, how many values do we need to find out from the table?
Two values.
Three.
Three values. Less than equal to 2 means 0,
1 and 2.
1 and 2. Now look at the binomial table. The Poisson distribution table. This quantitative type of papers online is a challenging task. Point 2.
Then we'll add the possibility.
Yes, then we add. It looks like this. So this table is in blocks. You can see first block, the second block, and so on. And horizontally, you can read lambda values. So can you locate 4.2?
Yes, sir.
So under that column of 4.2, lambda is 4.2. Under that column, you can read the values for when r x या r जो भी है is 0 पे, 1 पे, and 2.
2, right, sir.
And add them.
0.2138.
Point?
0.2103.
2138.
03. It is 03. Correct. So that means now if you answer it like this, that getting 2 or more successes, when the probability of getting 2 or more successes, when the average success is 4.2, the probability is 21%. Now, if I take this one, a slightly different case, on an average, 40 service calls are received during an 8-hour shift at a call center. What is the probability of receiving more than 10 calls during a particular hour? So what is lambda and what is r here?
Lambda is 40 and r is greater than equals to 10.
Yes, anyone else? What is r and x? What is x and what is lambda? First part A. Example 4, part A.
No. So 40 calls are for 8 hours, right? So we have to, if you are going to do it for per hour, we should do by 8.
5. Lambda is 5.
Yeah, lambda is 5.
Right.
Okay, sir.
So lambda is 5 calls per hour. Lambda is a unit also. Okay, not only number but unit also. Lambda equals 5 calls per hour. Because this 40 service calls is for 8-hour shift, and we are interested in finding out this per hour. So we will convert that lambda into that time interval, means hourly. And more than that, more than 10 means x
Greater than or equal to 10.
X greater
X is greater than or equal to 10.
Only greater than, not equal. Only greater than, more than 10. अब इसको कैसे करेंगे? More than 10 means 10 plus 11 plus 12 up to
40.
Yeah, up to infinity. That's it.
Up to 40.
No, up to infinity. That's it.
Yes. So in this case, the only way out is 1 minus. 1 minus probability of what?
X less than or equal to 10.
Correct. So either we have x greater than 10 or 1 minus probability of x less than equal to 10. Is this clear to you, all of you?
Yes, sir.
Yes, sir.
So you can't add it like 10 plus 11 plus 12 because there is no end there. So therefore it has to be 1 minus x less than equal to 10. And lambda is 5. So now with these two examples, you can understand how to express r or x, whatever, and how to match that lambda with x. Lambda का जो interval है, that should match with the interval of r. Am I clear?
So that 1 minus x, can you explain again? So we said x is greater than 10. And
yes.
It will go till infinity. So we want to take it.
That you can't do. What you can do is 1 minus x.
Yeah.
What?
That would be less than 10.
No, less than. If you do it like this, so one is x greater than 10, the other one is x less than 10. What about x equal to 10? Where will that go? So therefore, it is 1 minus x less than equal to 10.
Yeah.
दोनों चीजें होंगी, सिर्फ लेस देन नहीं होगा.
Yes.
10 cos को कहीं तो आना होगा ना.
Right. Got it.
Okay. Now we come to normal distribution. How many of you are not aware of this normal distribution? Those who have never heard or studied or come across normal distribution?
Yes, I'm not.
I think all of you in your MBA or somewhere before MBA means if you are a student of MBA now, then somewhere you must have done. Anyway, so normal distribution is that probability distribution which is generally used for continuous variables. And shape-wise, it is bell-shaped, symmetrical about its mean, and it is specified by its mean and standard deviation. So it's like this, bell-shaped. And this middle point, here we have x values of x. X is the variable we are talking about. And this point is the mean value, average. And other values are deviating from mean. And when we take this, when we standardize these deviation, it becomes standard deviation. So mean of a normal distribution, we express using mu, and its standard deviation as sigma. And it is 50% on this side because it is symmetrical about its mean. 50% this side, 50% this side. So this area represents the probability of x somewhere, and this is denoted by area under this curve, and another thing that you can see on the slide is 1 plus minus 1 sigma means if you take this much range plus x means mean plus 1 time of standard deviation on this side and x minus 1 time of standard deviation on this side. So this area will be approximately 68% of the total. This total area we consider as 1 because this is probability 100%. So plus minus 1 sigma that covers 68% of this area, and if you expand it on each side, mean plus 2 times standard deviation and mean minus 2 times standard deviation, then the area under this curve will be approximately 95%. And when we talk about plus minus 3 sigma, then it covers almost 100%. Now, since if you change either of the two specifications, means either you change mean or standard deviation, the shape will be different, or you can say the distribution will change. If you change either of the two, mean or standard deviation, or both, of course, then the distribution will change. So, and therefore, we can have almost infinite number of distribution for the same phenomena. मिसाल के तौर पे अगर हम बात करें कि नंबर scores obtained by students in the class, in QT class. So if the mean is say 60 and standard deviation is 5, it will be one distribution. If I change mean from 60 to, for example, 40 with the same standard deviation, the distribution will change and so on. So this way, depending on this different combination of mean and standard deviation, we can have a number of such distribution for the same phenomena. What phenomena? The scores obtained by the students in QT class. So there is a need to standardize that distribution, and that we call as standard normal distribution. Standard normal distribution, and for this standardization, we convert x is again x is representing that variable. In our case, if we are talking about marks obtained or scores obtained by the students in QT class, so x represents scores. So x can be converted into a standardized variable, what we call as z there. So, and once we standardize, we can use a standard table, a statistical table for solving the problem. And for that, this last point on this slide, z, it's not x bar, it is x, x minus mu over sigma. Please correct it. Z equals x minus mu whole divided by sigma. So mu and sigma will be known, x will be known. So corresponding value of z can be obtained from here, and then we make use of the normal distribution table. Is this point clear?
Yes, sir.
Okay, sir.
Let us see example 6 first. A placement company has conducted a written test to recruit people in software companies. Assume that the test scores are normally distributed with mean as 120 and standard deviation is 50. Determine the probability that a randomly selected score, or you can say determine the probability that if a candidate is randomly chosen, then it's what is the probability that his or her score will be greater than 200. I'm talking about first part A. So if there are say 1000 candidates who have appeared in this placement written test, of which the mean was 120 and standard deviation was 50. So if we randomly chose a candidate, what is the probability that his or her score is 200 or more? अभी 200 कहाँ से आया? मे बी टेस्ट का मैक्सिमम स्कोर शायद 300 रहा हो या 400 रहा हो. ठीक है? So this is how we should first understand the problem. Okay, what we need to calculate, what does this mean? Determine the probability that a randomly selected score is greater than 200. What does it mean? So we should first understand and then try to solve it. Now what we do, we draw this bell-shaped curve, mark this 200, mark this 120 on x-axis, which will be represented as mean, and then mark 120 where it is 200.
So your video is not visible.
Sorry?
Your video is not visible.
You're showing anything in the paper?
No, not showing. I'm just explaining this, what is written on the slide.
Okay, sorry. Yeah,
so draw a normal shape curve. Its mean as 120 and mark 200 also on this.
This is what's right. Okay. Yes, sir. Correct. Yes, understood.
So what is required is probability of x greater than 200. So I have shaded that area greater than 200 part. Can you see that?
Yes, sir.
Yes, sir.
Yes, sir.
And mean is 120, standard deviation is 50. Now we convert this into z. How? Z equals s minus mu over sigma. So how much is z now?
0.6.
0.6.
0.6. 1.6.
1.6. 1.6.
1.6 second decimal place. 1.6.
60.
60.
Acha, okay, 1.60. Now we find the probability for this z value. Is your table like this or different?
Yes, sir. Same.
Because my table reads all values from 0, z equals 0 onward, all positive values. And it is demonstrated here.
Yes.
Yes, sir.
So if your table is also similar, then it's easy now to explain. Otherwise, you may have a different format. So you have some z values here.
Yes, sir.
These values.
Yes, sir.
And some second decimal place written horizontally.
Correct.
So what is our value is 1.6. Z equal 1.6. 1.6. So you can locate 1.6.
Yes.
And find out its probability.
Yeah, I'm washing my
0.4452.
Yes. 4452.
Let me check now. 1.6. 0.44?
52.
0.4452, right. So which area does this 0.4452 represent? हमारे केस में which area is this? अगर just you look at this
Yeah, 0 to 1.6.
yes,
Mean to 1.6.
From the mean.
so that is in where is my that page which I was just showing. हमारी वैल्यू थी Z की
So what about these decimal places to the right of Z? Which are
just
placed?
hold on. What was the value?
0.4452.
So 0.4452 is basically this area.
Correct, sir. Yeah, from the mean. Yeah.
Mean to this point. And we are interested in which area?
Beyond that.
The right side.
Beyond that. So what will we do? We and from mean to its end, how much is the total area?
0.5.
0.5. So what we do? 0.5 minus 0.4452 will give you this probability.
0.0548.
So what is the probability that x is greater than 200 is translated into what is the probability that z is greater than 1.6? I hope you are getting this point. We have converted x greater than 200 to z greater than
1.6.
1.6. And this you can find out from the table. So now how will you express or interpret this 0.0548? What is this? The probability that if you or जितने भी candidate थे out of that 1000, if you randomly picked up one candidate, the probability that the candidate will be having his or her score more than 200 is only
5.5%.
5.5%.
5.5%. So this is how we understand. Similarly, now you can do this one, the second one, third one, and so on. The trick here is every time you may need to, most of the time you may need to use that 0.5 or 1. Sometimes you will be adding 0.5, sometimes you will be subtracting from 1, sometimes you will be subtracting from 0.5. So you need to have a clear understanding, and the suggestion is before solving a normal distribution problem, you should always draw a curve and shade your area. Which area you want to find out, so that will make the picture clear कि आपको 1 में से जोड़ना है, 1 में से घटाना है, 0.5 में से जोड़ना है, so that you can easily do. For example, now the first one, for a given normal distribution with mean 90 and standard deviation 15, find the following probabilities. Do the first part. There will be two values of x z here. I'm talking about this. There will be two values of z because why? Since we have two values of x here,
90 and 100 both.
90 and 100, therefore two corresponding values of z. Z1 and Z2. So find out Z1 and Z2. Z1 will correspond to 90 and Z2 will correspond to 100.
But sir, since the mean is also 90, should we find out 90 separately?
Sorry?
The mean itself is 90.
Mm-hmm.
So should we find out separately 90 separately?
No, whatever is the mean, but the probability which you want to know is what is the probability that a randomly chosen X varies between 90 and 100. This you want to know. So there are two values of X, 90 and 100. So corresponding values of Z will be Z1 and Z2. Z1 for 90 and Z2 for 100. So it's by chance that here one value of X is its mean.
The y-axis itself is mean. Yes. And
so what are the two Z values?
So 0 and 0.2486.
0 and
0.2486.
0.67.
So 0 and 0.66 or 67 we can say.
Okay. So now we shade the area, required area, draw a normal curve and indicate 90 and 100 and then shade the required area.
So probability of Z1 is 0. Probability of Z2 is 0.2486.
Only 468, right?
Sir is there?
sir is not here.
Ma'am, I don't understand why do we have two probabilities? We only will have one probability, isn't it?
But that's the area between that mean and this 0.667, right? 100.
The entire area is the probability.
Yes. So
No, because I think, okay, you're correct. Because sir said in this particular case, they don't happen to be the mean, right? So
yeah,
that's right. But it is 2486, no? Not 46.
Yeah, 2486.
Yeah,
That's what.
24.9%. Yeah.
So in the table, like if you see, it is 0.66, right? So which is 0.2257.
0.67 we took because it is 0.6666, no?
Yeah, so 0.67, do we have it on the table?
Sir, you first
0.6 and 0.07.
Exactly.
Yeah.
0.07. Sir, you have to move towards your right now.
Yeah, so the right is the value is 0.2454 on
That is for 0.06.
Yeah.
So next number 0.07 is 2486, right?
Actually, 6 is repeating infinitely, so we approximated.
Got it. Yeah. I think, yeah, I understood. I added both. Sorry.
Actually, guys,
Yeah.
my question is how many sir and
Yeah.
ma'am are there? How many sir and ma'am are there in the group? Anyone can please tell?
समझा नहीं तनिज आप क्या बोल रहे हैं कितने लोग हैं हम लोग
We are telling each other sir and madam. So it's no sir and madam.
Okay. Just a form of
teacher,
gesture.
Yeah. So
Okay,
we are calling Kaushik sir and we are.
Okay, fine.